My name is Kaat. I am a PG at KU Leuven in the research group Leuven Economics of Education Research. Normally I would be with you in Budapest, but unfortunately due to COVID we had to cancel. Nonetheless, I'm very happy I can present my work at your seminar in this online format. Today, I would like to present the results from a field experiment where we examine the determinants of peer effects during learning. This is a joint work with Christophe de Witte, my promoter, and Wouter Schelveld, my co-promoter. Note that it's quite preliminary work, so any suggestions or comments on the experiment or analysis are very welcome. So I will first outline the objectives of our study a bit. In general, we were interested in examining the effectiveness of an entrepreneurship education program via a field experiment. And in particular, the objectives of the study were fourfold. So first, we wanted to evaluate whether students in treatment schools performed better in a knowledge test and had more positive attitudes toward entrepreneurship after the program. Second, we were interested in examining whether peer learning is more beneficial than individual learning during the program. Third, we were interested if peer differences are important when learning in pairs, so whether it's important if you're very similar to your peer or different with respect to multiple cognitive and non-cognitive skills. And then finally, we were also interested in determining the underlying mechanism of peer learning. And for this, we used two theories from the educational science literature, so a cognitive and a motivational theory. So as many of you know, the literature on peer effects is quite extensive. For instance, you have studies that compare teams with individuals, such as Cooper and Kegel, who find that teams play more strategically than individuals. There is also a handful of studies that randomly pairs peers in order to study heterogeneous peer effects, such as, for instance, Bandiera and colleagues, who randomly assigned workers and found a convergence in effort between low and high productivity workers. And then there is also quite some literature about peer effects in the educational setting. For review, for example, see Apple and Romano. Note, however, that most of these studies look at average or homogeneous peer effects by, for example, exploiting random class assignment or dormitory assignment. But there are also some studies that are more closely linked to our research. First, you have Fafshaw and Mo. They investigate peer effects in a computer-assisted learning program in Chinese primary schools. And what makes their study so useful is that they developed a proper identification of heterogeneous peer effects. And we will base our identification of peer effects also upon their study. They find that high achieving students do best whenever they're paired with low achieving students and vice versa, and explain this via a knowledge exchange. There are also some studies that already look at the importance of peer differences, such as, for example, with respect to personality traits, peer orientation, so whether you prefer working in group or individually, and prior knowledge. And then finally, in the educational science literature, there is already a lot of literature about what determines successful peer learning. So it has been two theories have been developed. On the one hand, you have this motivational theory that assumes or that states that students working in pairs are just more motivated, and hence this induces a learning benefit. On the other hand, you have the cognitive theory, which states that students working in pairs will have a learning benefit because they can discuss the content of the material with each other. They can engage in higher quality understanding and more. I found two studies that look already at these two mechanisms, so Eisenkopf and Kimbrough and colleagues, and they do this in a laboratory setting. So As the literature on peer effects is quite extensive, it's of course very important to outline our contribution in the literature. Most importantly, what's different in our study, investigate peer effects in the learning process. So in contrast to many studies that look at what the impact is of a peer sitting next to you or peers in the class on, for example, student outcomes at the end of the academic year or during midterms, we really look at the effect of you being assigned a peer and working closely together on the program. What's then the impact on your knowledge and attitudes after the program? And then a bit in line with this, we look at peer effects at micro level. So instead of looking at peer effects at class or even school level, we look at what's the effect of a peer sitting next to you working on the program together. Until now, these two contributions are actually fairly in line with the study by Fachan and Wo. However, what these authors are unable to determine is what determines successful peer learning. So they explain their findings through a knowledge exchange, but they don't explain how this knowledge exchange occurs and why. So using a large set of student and peer characteristics, on the one hand, we really look at what's the importance of being similar or different to your peer. And we look how we can explain peer learning via these two theories as developed in the educational science literature. So is it because your motivation is higher that you do better in peers, or because you just have the opportunity to discuss the content, etc. And to establish our results, we conducted a field experiment with 2,600 students in 95 Flemish secondary schools. So we're really able to look at the benefits of peer learning and its underlying mechanisms in a natural classroom environment, which is different from the studies I discussed on the previous slide, who looked at these mechanisms in a laboratory setting. So I will now discuss the experiment a bit more. So for our study timeline, in December 2019, schools were able to register for our program. So teachers teaching in the 9th to the 13th grade were asked whether they would like to participate in this entrepreneurship education program with their students. And then from the schools willing to participate, we sent them the pretest mid-January. And based on the completion of the pretest, we then randomized schools into conditions. We randomized at school level to ensure or to avoid spillover effects across classes. And we randomized schools at 3 levels. So we follow Fachan and Wo in this randomization procedure, as by randomizing at these 3 levels, we ensure that we obtain heterogeneous peer effects as well as suitable control groups. So at the first level, we assign schools either condition. Then within the treatment condition, we assign schools to either the pair or individual treatment. And within the pair treatment, we then ask teachers to randomly assign students to pairs in the class. So this last level is at randomization occurred at individual level. And then students in the treatment conditions received the program, where students in the individual treatment worked alone on the material, whereas in the pair treatment, students worked in pairs. The control group received no education meanwhile. And end of March, teachers were expected to have finished the course and given the first post-test to students. Then a couple of weeks after, so 4 to 6 weeks approximately, we also sent a second post-test to students in the treatment condition to measure the longer-term impacts of the program. The entrepreneurship education program was designed as 4 lectures of 50 minutes approximately, and it was a computer-assisted program which was designed as a business simulation game, also including additional exercises and information sheets. During the business simulation game, students had to make decisions for a fictitious scooter company. They had to manage the production, logistic, marketing, etc., to maximize profits of the company. In the entrepreneurship education literature, such business simulation games have been considered as useful as it allows students to engage in entrepreneurial activities in an experimental setting. And it has been found to help reduce the uncertainty as to how suitable entrepreneurial careers are for the students themselves. We also provided additional exercises and information sheets, as it has been found that this enhances the effectiveness of simulation games. Students completed the program either individually or in pair, so depending on the experimental condition the school was assigned to. And if students had to work in pair, they had to share a PC. And then because we had this computer-based environment, which automatically provided instruction and feedback to the students, teachers were actually expected to intervene as little as possible. So besides a teacher manual, no teacher training was provided. And this really ensured that we were able to isolate peer effects from additional teacher effects. And then finally, we also gave a reward to the 6 best performing students in the business simulation game. So that way we actually created competition and incentivized students to perform well during the program. So as mentioned, students had to complete pre and post tests. And from these tests, we derived multiple outcome measures. First of all, in the pre-test, we captured we surveyed a lot of background characteristics of the student and also their baseline knowledge in the topic. So we collected student and family background characteristics such as their gender, their age, their socioeconomic status, but also parent entrepreneurial activities. Second, we measured the personality traits of students. We did this via the quick Big 5 scale, and the Big 5 scheme includes the following 5 personality dimensions: so extroversion, agreeableness, consciousness, neuroticism, and openness. We also surveyed students' motivation for the topic, their peer orientation, so whether they prefer working individually or in group. And following the entrepreneurship education literature, we also measured their intentions to become entrepreneur, their attitudes toward entrepreneurship, and their risk-taking preferences. For instance, with the items, I intend to start my business within the next 10 to 15 years. Students had to respond on these items on a 7-point Likert scale. And then their baseline knowledge in the topic was assessed using a 10 questions multiple choice test. In the first post-test then, which was administered to capture the short-term impacts of the program, so immediately after the program, we measured their knowledge of the topic again, as well as their entrepreneurial intentions, their attitudes, and risk-taking preferences. Moreover, we also assessed their motivational state during the program, and their performance during the business simulation game, so whether they made profits or losses during the game. And then for students in a pair treatment, we also asked them to complete a peer assessment. This is to measure the quality of cooperation, and we did this via the what happens in the group questionnaire. So in this survey, we actually got information about how well the cooperation was between students, so whether they were dominated by their peer, whether they discussed the content with their peer, whether they agreed before making a decision, for instance. In the second post-test, this was only assigned to students in the treatment conditions, and here we just surveyed their knowledge in the topic and their intentions, attitudes, and risk-taking preferences. So if we move to the data, our sample, as mentioned, included 2,629 students in 95 schools, and these students completed the pre-test. So based on this sample, we randomized them into the 3 conditions. Note that in the pair treatment, there are significantly more schools, as we actually double the size of the other conditions. This is because we wanted to make sure that this condition was large enough to capture student variation concerning these peer differences, etc. Unfortunately, only 1,071 students also completed the first post-test. So our final sample includes 433 students in control, 162 students in the individual treatment, and 476 students in the pair treatment. This means we had an attrition rate of 59% from the pre to the post-test. And the main reason for this high attrition rate is the school closures because of COVID. So teachers were able to plan the lectures until the end of March, but mid-March schools had to close. And that is why we were missing such a large sample of students, because they were just not able to complete the program and the post-test. Now, we expect, of course, that it was rather random whether the teacher planned the lectures before the school closure or not. But of course, we have very high attrition rates, which we should look into more in detail later on. In the second post-test, we then have 68 students in the individual treatment and 144 in the pair treatment. Again, the attrition rate is quite large. The main reason here is because schools were still closed by that time. So teachers had no control of which student completed the test or not. And as this was not compulsory to the students, this explains, I think, this large dropout. Now, this table looks at the importance of the attrition for the first post-test. So I do this by regressing multiple school and student characteristics on a constant, an attrition dummy, so whether the student completed the pre and post test or not, a treatment dummy, an interaction of the treatment with the attrition dummy, a dummy for the pair status, and then again an interaction of the pair status with the attrition dummy. And then we can see from these two interaction terms whether attrition was selective, yes or no. Overall, yes?
The attrition is 1 if somebody is dropped out, or 1 if somebody is kept in the...
Attrition is 1 if he didn't complete the post-test, so if he dropped out, yes. So what I see is that mostly older students drop out on average, and students from non-academic tracks. And given we observe some significant interaction terms, so the treatment with the attrition, this paired status with attrition, we do conclude there is some selective attrition going on, and in particular for the academic track. Accordingly, I think it's important that we assess the robustness of our results later on, for example, via a bounce analysis or other. I also did this analysis for the second post-test. However, there I don't find selective attrition, so there is no significant difference between conditions of who dropped out or not. Then for the final sample, I present here the sample descriptives. So overall, we find that for our final sample, the sample is rather balanced. So this first p-value compares the control with the two treatment conditions combined, whereas the second p-value in the table compares the individual treatment with the pair treatment. What we find is that in the control condition, there are significantly more females in the final sample, and that in the pair treatment, we see significantly less students speaking the official language at home, so Dutch, compared to students in the individual treatment. But most importantly, we see that at baseline, the knowledge score, so the baseline score, the intentions, attitudes, and risk-taking preferences are not significantly different across conditions. So these are our main measures where we look also at the improvement over time. Here we observe no significant difference at baseline. So if we move to our empirical strategy, first of all, we are interested in whether the program was effective. So whether students in treatment schools do better than students in control schools, and whether there is this learning benefit of working in pair versus working individually. So this YIT+1 is then the standardized value of an outcome measure. For instance, the test score or the attitudes towards entrepreneurship. T is then an indicator of the treatment status. P is an indicator of the pair status. YIT is the initial value of the outcome. XIT are some student characteristics for which we observed baseline imbalances and selective attrition. And these are here to aid precision. Note that we cluster the standard errors at the school level, so the level of randomization. So alpha then captures the effectiveness of the program in general, and beta is then this average incremental gain of being paired versus not.
Can I have a question?
Yes.
Why don't you estimate the fixed effect model or regress? Use the change between the two tests as independent variable?
I could do that as well, indeed, but as we have this experiment where normally we assume that at baseline everything is the same across conditions, we can here actually just compare the post-test scores and control for some student characteristics. Because given that we don't observe differences in the baseline scores or the baseline values for the attitudes, etc., such specification is usually enough. Yeah.
Okay, thanks. Just a minute.
Here, where I look at the effect of the treatment depending on the initial knowledge of the student. And I do the same for the pair treatment. So you have beta 1. This is actually the effect of being paired versus not, depending on your initial knowledge. And as a measure of initial knowledge, I also include the class mean. So it's actually your initial knowledge relative to others in the class. And I think this is reasonable to include as if a teacher teaches to the class and, for instance, your or the average student is high performing, then the teacher will go faster. And it means that the program will probably, because it's computer based, help the laggard students to catch up. So this, if gamma is, for instance, negative, it means that a student with high initial knowledge benefits less from the treatment. If this beta 1 is negative, it means that a student with high initial knowledge benefits less from being paired versus not. And then finally, the last specification I look at, which is rather long regression model, but the only difference with the prior model is that I now include information about the peer and an interaction between student characteristics and peer characteristics. Is that this beta 2 and beta 3 give information about the peer. So this means that a student benefits from being paired with a peer with high initial value of y of x as compared to being paired with an average peer. Beta 4 and beta 5 then actually provide information on the importance of peer differences. So this means that if the student itself has high initial values of y or x, then does he benefit from being paired with a peer with also similar values, so high values of y or x, as compared to being paired with an average peer. So I hope this is clear because it's rather long regression. But so beta 2, beta 3, beta 4, and beta 5 actually show the importance of peer effects, the importance of peer differences in our model. So if we now turn to the results, first of all, we are interested in whether the program was effective or not in terms of improving student score in the knowledge test. So here column 1 shows the effect of, column 1 shows the day specification. So we find that students in treatment schools do significantly better in the post-test than students in control schools. So they score 0.42 standard deviations higher on the post-test on average. What's in contrast to the literature is that if students are paired, they actually do not do significantly better. So this paired estimate is insignificant and should show the average incremental gain of being paired versus not. If we then look at the second column, which shows the heterogeneous treatment effect, we find that the treatment was especially beneficial for low achieving students. So we find that if you yourself was a high achieving student, then the treatment was less effective. So you have minus 15 standard deviations on the score. Possibly this is of course because there was less room for improvement for these students. And interestingly, we also find that there is a heterogeneous effect of being paired versus not. We find that high achieving students actually do worse when they are paired, when they had to work together on the program versus working individually. And this is in contrast to the literature that states that peer learning is beneficial for all students, because here we find a negative effect for high achieving students.
Sorry, Kat, can I have a
Yeah.
Isn't it just a simple convergence to the mean? So students who scored high at the beginning will score lower because they cannot go higher, while students who scored low at the beginning will score higher because they cannot go lower.
I think indeed it's an explanation for this for this heterogeneous effect for the treatment, because they already scored quite high. They indeed cannot go even higher after the treatment. But this paired estimate actually just shows the average incremental gain of being paired versus not. So it shows the gain of working in per 2 versus not. So this really shows that students who were high achieving do worse when they work in group rather than individually, I think.
Okay, thanks.
And then from the educational science literature, from the entrepreneurship literature, it stated that entrepreneurship education programs can also change students' intentions to become entrepreneur, and that this can be explained by their changes in attitudes towards entrepreneurship and their risk-taking preferences. So we examine whether this is also the case for our program. And what we find is that on average, so the treatment on average, increases students' attitudes towards entrepreneurship by 0.13 standard deviations, and their risk-taking preferences as well. What we don't find is that students in the paired treatment have significantly more positive attitudes or risk-taking preferences. So again, we see no learning benefit of working in pairs versus individually. Further, we find also no significant differences in students' entrepreneurial intentions, so intentions to become entrepreneur after the program. Possibly this is because the program was rather short, so only 4 lectures. And moreover, it should also be noted that the aim of our program was not to increase intentions to become entrepreneurs. So it's even a decline in intentions to become entrepreneur could also even be socially valuable, as then you could say that the program succeeded at convincing those not suited for entrepreneurship to become entrepreneur. So what we have until now is that overall the treatment seems to be effective, but that we don't find this learning benefit of being paired versus working individually, what has been established in the literature for so long. So we try to explain why we can't find or why we have this absence of learning benefit for peer learning. And one way we try to explain this is by examining whether peer differences matter. So whether it matters if the peer sitting next to you is very different from you or very similar to you. in this table, I report conditional effects, meaning that I actually estimate the whole regression model, but only report the interaction terms between the student values and the peer values. Note that there are also multiple ways of defining peer differences. So here we only look at the absolute difference with respect to the class mean, but other ways would, for instance, be to take the quadratic or exponential value of peer differences, such that if you're very different from your peer, you would receive a larger weight. However, I find that the results are rather robust to these different methods of defining peer differences. In the regression model, I also included gender pair dummies. And what we can conclude overall, if we look at differences in prior knowledge, differences in the personality traits of students and their motivation for the topic, that it seems that peer differences are unimportant. So in particular, students with high values of initial knowledge, of the big 5 personality traits and motivation for the topic, they do not seem to benefit from being paired with students with similar values as compared to a peer with average values. So what I... Yes.
What is the scale of these trait measures? Because I do not know whether these parameters are very small or...
Yeah. You mean the scale of the, for example, the personality traits, or?
Yes.
So for the personality traits were measured on, each personality trait was measured on a scale of 42. And then you compare, or your value is your own value minus then the class mean.
Yes.
So how different you are to the class mean.
And how correlated are these traits measured?
With each other?
Yes.
There is, actually, I should check this indeed. I did this in another study and then it was fine. But I do indeed, maybe I should estimate them separately. But I did check for the correlation between the characteristics I included in the regression. That was fine. I should check this. Thank you. But normally, actually, I checked whether there was multicollinearity in this regression. That was not the case. So from the table, I think it's a big conclusion to draw from this table. But for now, I conclude that that this implies that students working in pair do not need to have very similar or different cognitive or non-cognitive skills as their peer for peer learning to work. Of course, here I only look at what's the impact of you having a high value and your peer having a high value compared to you having a high value and your peer an average value. I think it could still be interesting to also look at you having a high value and your peer having a very low value. So this I cannot say from this regression. So then I also analyzed these motivational and cognitive theories from the educational science literature. So what determines successful peer learning? Is it because students are just more motivated, or is it because they can discuss content with their peers, etc.? So we analyzed students' motivation during the program, which was assessed in the first post-test for students compared to control. And what we see from this regression analysis, if we look at this paired estimate, that students in the pair treatment actually do not report to be more motivated than students in the individual treatment. So this contrasts the literature, which stated that students are more motivated when they work together. However, it is in line with our results, as we also did not find a learning benefit, which could potentially then be explained by also no increase in motivation when working together. And then next, I also look at this cognitive theory, so whether cooperative or peer learning works because students can discuss content with each other. And for this, I actually look at the quality of cooperation between students. So we explore actually here whether we can explain the negative effect of peer learning for high achieving students just by poor quality of cooperation. So what I did here was a subgroup analysis for students reporting either low quality of cooperation or high quality cooperation in the peer treatment. And if students reported high quality of cooperation, then it meant that students reported they really helped each other, were less likely to be dominated by their peer, were more likely to agree with decisions, etc. From the cognitive theory, we would then expect that if quality of cooperation is high, peer learning is more effective than individual learning for all students, as low and high achieving students learn them from each other via peer-to-peer teaching. In this table, we find that the theory is partially confirmed. So we find on average that the peer treatment is more effective when students report a high quality of cooperation. So we see that the estimates for the peer dummy is significantly different in the subgroup analysis. So this indicates that while peer learning is more effective when quality of cooperation is high, we still find that peer learning is still not more effective than individual learning, but that quality of cooperation is something important.
Why do you have so many observations? In the last table you had 1,000 and now you have 1,600.
So I do this subgroup analysis, but the subgroups are actually only in the pair treatment. So students in control and the individual treatment are still the same in both regressions. But in the pair treatment, I differentiate between students reporting low quality of cooperation and high quality of cooperation. So that's why the samples are larger when you count them together, if that's an answer to your question.
I didn't get that.
So the question was why that the subgroup analysis have such big samples, right? And that's why, that's because students in the control and the individual treatment are still the same in both analysis, but the subgroups is only looking at the pair treatment. So only in the pair treatment, I separate the two groups, but for the other two conditions, they are still in both regressions the same, if that makes sense.
Okay, thanks.
Yeah. So then I also find that when students in a pair treatment report high quality of cooperation, then high achieving students actually do significantly worse when being paired versus not. So this is quite a striking finding, again, which contradicts the literature, saying that high achieving students do better because they can explain information to their peers. Here we find that when quality of cooperation is high, so when students really engage with each other, peer learning appears to have a negative effect for these high achieving pairs. Now, note that this is quite suggestive evidence, as we don't find a significant difference between these two estimates. And then a final analysis I did for now was to look at the persistence in effect. So I look at the results from the second post-test. Overall, from these graphs, I can conclude that the improvements seem to fade over time. So we find that, especially for the post-test scores, compared to control, we see a decline over time. And another finding is that, again, even in the second post-test, we see no significant difference between both treatments. So students who had worked individually did not do any differently in the second post-test as those students who worked in pairs. So already at the summary of my findings. So I had quite some analysis, so I will now briefly summarize them for you. what we find is that there is a short-term effectiveness of the entrepreneurship education program. So we find that the test scores improve on average by 0.43 standard deviations. We find that low achieving students benefit most. Students' attitudes towards entrepreneurship and risk-taking preferences also improve by 0.13 and 0.11 standard deviation. However, unfortunately, what we saw on the last night is that these improvements seem to fade approximately 6 weeks after the program. Then a very important finding, which contrasts the literature, is that we don't find a benefit of peer learning. So students working in pairs during the program actually performed equally well as students working individually. And for these high achieving students, we even saw that they performed worse when working in pairs compared to individually. Then we looked at these peer differences or similarities, whether this was important to explain successful peer learning. However, we found that this wasn't the case. Another finding which contrasts the theory in the education literature is that peer learning does not increase the motivation of students during the program. And then finally, we saw some importance of the quality of cooperation. So when students reported that the quality of cooperation was high, then we saw peer learning was more effective, however, still not more effective than individually learning. And we found some suggestive evidence, however, that high achieving students appear to do worse in this setting. So whenever they really had to engage, or when they really engaged with their peer, they had lower test scores when working in pair rather than individually. So our main finding is actually that we contradict the literature in stating that peer learning is more beneficial for all students, as we don't find an increase of motivation or a mechanism a mechanism of peer-to-peer teaching, as these high-achieving students do not appear to benefit from it. So what I haven't really done until now was to look at the importance of attrition, which I think is very important, as we had this very high rate of attrition. I did look at the importance of our baseline imbalances using a matching approach. So I did a percent exact matching to ensure that all conditions were similar at baseline, and I found that the results were robust against this specification. Another thing that I think can be interesting to still look at is the performance of students during the program. So to look whether students had profits or losses, and whether this is related to whether they worked in peers or individually. So that was it until now. Thank you so much for listening. Are there any questions or comments? I'm happy to hear it.
Thank you very much. I think Daniel has a question for me.
Yeah.
Yeah. Did I just miss it? You haven't showed a regression on the long-term results.
Yeah, I showed the graphs. Wait, here. So here I show how the scores evolve over time. And what we find, unfortunately, is that there is no persistence in these improvements. So over time, we find that the test scores are actually almost similar to the control condition. Now note that for the control condition, we didn't have their second post-test scores. So we didn't ask for a second post-test for these students, as they received the material right after the first post-test. So we use their post-test scores as second post-test scores, as we expect no learning effect for the control condition over time.
Okay. Thank you. Laszlo Halpern has also a question.
Yes.
Yes, and perhaps comment as well.
Yeah.
So I think that the key is here that what is the content of the cooperation and how do they perform it. And before asking that, I think there is perhaps a technical question.
Yeah.
When the students were evaluating the quality of the cooperation, were they already aware of the results?
Do you mean the results of their tests, or?
Yes, yes.
No, so they didn't know. Actually, students were unaware of how well they scored on the pre-test to post-test. Only on the second post-test they received their score.
So then we do not know exactly that how the quality of the cooperation can be really evaluated, because they were just, so to say, being able to infer or make a judgment on the peer, whether they were, so to say, friendly or whatever.
Yeah.
But this might not be in any relation with the so-called outcome. So that's why the quality of the cooperation, this is a key concept, how to evaluate it.
Yeah. So indeed,
yeah.
what we did here, it was just in a post-test, give the students a peer assessment, and they had to rate on a scale of never to a lot, whether they helped each other a lot, whether they discussed the content a lot. So it's all self-assessed, that's true.
Okay, but the cooperation should have some sort of aiming at the outcome, in function of the outcome. So then I think it would be rather interesting to see that what would have been the evaluation of on the cooperation, knowing the results.
Okay, yeah, indeed, we don't have this. So why would this be interesting? Sorry.
Because how the cooperation would be evaluated differently by the participants in function of the results of the outcome.
Indeed, what you would expect is that if students know the results, they would rate their cooperation differently.
Exactly.
Okay. Yeah.
And the other point is that what is the content of the cooperation? I mean, pairwise they sit in front of a screen.
Yes.
And they just discuss which button to hit, right? So exactly, this is something a very special and very curious cooperation. Perhaps they haven't done that type of cooperation before. So that might not be a sort of cooperation in the proper sense of the word. I mean that this is very specific. And if they were just playing with a mobile phone or other, and so to say, never sit in front of a screen of a PC, then the cooperation is somewhat rather specific.
Yeah. So I think indeed it's important to really clearly define what students in the pair treatment had to do and what students in the individual treatment had to do.
Exactly. And what is the cooperation in that sense? And just have an idea that how does it happen in the cooperation if you know the who. So there is a different pair between the pairs, then the cooperation might be different, and it might not be in relation with the assessment of the quality of the cooperation.
No, I agree. Thank you for this comment. I will look into it more detail, and really, indeed, I think it's important to define what or how students then work together. So they had to, indeed.
And then you might, so to say, come to this type of final conclusion, because you have to dig deeper in this cooperation and the quality, so to say, assessment of the quality of the cooperation. Okay?
No, thank you so much. Thank you.
Thank you very much. Is there any other questions? If not, then thank you very much for the presentation. It was very interesting.
Thank you so much for having me.
Thank you. Thank you.
Thank you.